All right, our homework last night was page 436, number 11. So we're going to go through these. You had 2x plus 3x squared minus 7 minus 8x squared. First thing, inside of each grouping symbol, there's nothing that I can add or subtract or combine. So now I need to get rid of this subtract symbol here. So the first one comes down exactly as it is. This now gets given to the 7, so that looks like subtract 7. This is going to change this. This looks like a negative 8, so now that's going to make that a positive 8. So that looks like plus 8. Now I'm going to rearrange these using commutative property. So that's 3x squared. It's positive because of this plus 8x squared plus 2x. I'm using plus because that's a positive 2x minus 7. Now I'm going to combine any terms that's alike. So I get 11x squared plus 2x minus 7. That is in standard form because of the degrees. This has a degree of 2 because of your second exponent here. This is a degree of 1 because your exponent of 1. And this has a degree of 0 because it's a constant. So my degrees are in order from largest to smallest. Let's move on to 13. Okay, looking, there's nothing inside each grouping symbol that I need to do. So I'm going to start and combine things. Because this is a plus, everything in here stays the same. I'm going to group things together. And I'm going to add. So that is 2z squared plus z minus 11. Again, degree of 2, degree of 1, degree of 0. That's in standard form, so that is my answer. 15. Again, nothing to do with any of the grouping symbols. This is a plus, so I'm just going to start and get rid of the grouping symbols. I'm going to rearrange so my terms are alike. This is a negative 5b squared. Now I'm going to actually combine these terms. So this is negative 2b squared. These are in descending order, so that is my answer. Nothing to do inside of the grouping symbols. It has an add, so I'm just going to get rid of the grouping symbols. And remember, the more practice you have, you can start and actually skip steps. This is one of those steps you possibly could skip. The next one is another one you possibly could skip. I'm just going to rearrange. And then I'm going to combine like terms. And I am in descending order. This one does have a degree of 2. This one also has a degree of 2. I'm going to put this one first because it has one variable that has a degree of 2, whereas this one has 2 variables. Both of those are to the 1 power. So my x goes from x squared down to an x1. So therefore, I'm going to put that in descending order in that way. Okay, nothing to do with inside of the grouping symbols. I do have a subtract here, so that's going to change every sign that I have there. So the first one stays exactly the same. The second one now, this was a positive, so it's going to look like a negative, which makes that look like subtract. This was a positive, so now he's going to look like a subtract. This was a negative, so he's going to look like a positive. Now, get my terms together. Just counting my terms to make sure I've rearranged them all. Add things that are alike. This one has nothing else that's alike, so he just stays the same. This one does have something that looks alike. I'm sorry, let's go back and correct this. This was a positive, so that should be plus. So that should look like minus 1 rxt. Understand there's a 1 coefficient here. I do not have to write it though. Now again, this one has a degree of 3, this one has a degree of 3, and this one has a degree of 3. At this time, I chose to write this one first because my r has a second exponent. These r's only have a 1 exponent. Then I wrote this one second because x and x both have a 1 power here, and then I start to increase. So I did it in that order. There's nothing wrong if any 3 of these are interchangeable as well. Again, nothing to do inside, so this is an add, so I'm just going to drop all my grouping symbols. I'm going to go ahead and make this a minus 6 because of this negative 6 here. I'm going to rearrange. I've grouped together. Now I'm going to add. And those are in descending order. I'm going to do this one first because it has a degree of 3, degree of 2, degree of 0. Says point, nothing to do with inside of any grouping symbols. All of these have my pluses. So I'm going to now drop all my grouping symbols. On this one, while I'm dropping my grouping symbols, I'm also going to place all my same terms together. So I have a 4x plus 7x minus 2x. That's all appeared here, here, and here. I'm going to go to my y's. Again, those appeared from here, here, and here. And then now I'm going to add my z's. I want to make this a minus 9 because of the negative 9. So now, once I drop the grouping symbols and I arranged in one step, then I'm going to go through and do these. So that's 11x minus 2x, so that would be 9x. I have 7 minus 3, which is 4y. And I have a negative 6 plus a negative 2 plus negative 9, which is negative 17z. All of these have a degree of 1, so I'm going to put these in alphabetical order, x, y, and z. Nothing to do inside the grouping symbols, but I do have a subtract, so I am going to rewrite this one the first time through changing my signs. So this was a positive, so that looks like a negative. This is a positive, so that looks like a negative. This is a negative, so now he's going to look like a positive. Rearrange. Go ahead and get all terms together. So this gives me 2c squared. Remember there's a 1 as my coefficient here, so 3 minus 1 is 2. I'm typically going to write this without the 1 in front of that, and that would be my answer. '27, it asks you to write a polynomial that represents the perimeter of the figure at the right. We know perimeter means you're going to add all sides together. So you're going to have 3x minus a half. Oops, I'm sorry about that. Minus 1/2. And I'm going to add 2x plus 1. I'm going to add 2x plus 1/2. And I'm going to add 5x plus 1/4. Nothing to do inside the grouping symbols, so I'm going to now rearrange things. So 3x plus 2x plus 2x plus 5x. Those all come from my x terms. Minus 1/2 plus 1 plus 1/2 plus 1/4. Once I add these, I want to have 3 plus 2, which is 5. 5 plus 2 is 7. 7 plus 5 is 12. Here, this negative 1/2 and this positive half cancel each other off, so I am left with 1 and 1/2, 1 and 1/4, I'm sorry. So that would be my final answer for that one. That would be the perimeter of the polynomial. In 29, it says the perimeter of the figure of the right is represented by the expression 3x squared minus 7x plus 2. That's the perimeter. And they want me to write an expression that represents the measure of the third side. Well, I know that that perimeter is what? I'm going to call the missing side y. Okay, y is my missing side of the triangle. I'm going to combine what terms I can over on the right. So 2x squared plus x squared is 3x squared. So I've used this one and that one. Here I have a negative 1x and a negative 10x, so that looks like negative 11x. And here I have a negative 4 and a 6, so that looks like plus 2 plus whatever my value of y is. Well, if I get these on the same side, I'm going to subtract 3x squared. So what happens here is those eliminate each other. So I'm left with this. Because I'm wanting to find out what y is, I want to isolate y. So let's get rid of this 11x. So this now gives me 4x plus 2 is equal to 2 plus y. I get rid of this 2. Again, I'm isolating for y. That eliminates both sides. So the missing side of the triangle would be 4x.